my name is Leia, and in today's session, we're going to be talking about custom views and animated transitions. All right, so what are we actually going to do? Well, one of my favorite apps to come out this year was the brand new Apple App Store app. The App Store that used to be this boring and plain-looking app is now a compelling gallery of useful information and beautiful interactions. So first, we'll talk about how we can use generics to help us manage the Today tab and create more dynamic and reusable UI table views and cells. Next, we'll talk about how we can use We'll talk about the more exciting part and create the custom modal presentation and dismissal transitions of the Apple App Store app. And then finally, we'll learn a trick that makes it very easy to create seemingly complex animations by taking view snapshots and using scrolling and interpolation to drive our interactive transitions. All right, so let's get right to it. So UI table views and UI table view cells are pretty great. They're like the bread and butter of iOS development. But they can be pretty cumbersome to deal with by using Apple's out-of-the-box components. And they're kind of hard to reuse. So imagine you're creating this table view with a custom cell like this one. So first, you create your table view, and you add it to your view. Next, you create a custom cell class. Then you register the cell, and you have to figure out how to manage the identifier. So you probably add it as a constant to the cell class, or you use the string describing thing. And finally, you have to use this nasty guard to unwrap the whole thing, and then if that fails, you just return like a normal UI table view cell. So as you can see, this is a bit of chore and messy to deal with. And on top of that, if we now want to reuse this cell view as something that's not a cell, but a regular view, we have to decouple the cell and the view, hack it somehow, and refactor a bunch of code. So basically, the UI table view needs some help. We get some feedback from that room. But luckily, there's generics. And with the power of generics, we can turn this into this. And we can turn this whole guard mess into this beautiful one-liner. So how can we do that? Well, first, I'm going to give you a super quick primer on generics for those of you who haven't used them before or you've just gotten a little rusty. So generic programming is a way for you to write code that completely abstracts the data type. So let's say that you have to write a function that gets us a minimum of 2 inputs, and it has to work for integers and strings. We could do something like this. Int min takes in 2 integers and returns the smaller of the 2. And string min does the same for strings. As you can tell, the method signatures are different, but the actual bodies are identical. So not only do we have 2 functions, but the code inside them is repeated. With generics, we can reduce these 2 functions and remove the redundant code. So instead, we can write something like this. Generic min takes in an abstract type t in the angle braces that is conformed to comparable. And then we can use this function on any type that conforms to comparable. For example, integers and strings. And we get the same result, but with much less code, much less complications. And it's a reusable function. So how does this apply to table views? Well, we can add an extension to UI table view with 2 new functions, one for registering the cell and one for dequeuing it. In the register cell function, we create a new abstract data type that we'll call cell that is constrained to being a UI table view cell. And then we pass the type of that cell to the function. in the DQ reusable cell. We do the same, but this time we also pass the index path, and we return the cell. And our code looks a lot cleaner now. So we basically made the reuse identifier obsolete. So that is step 1. Step 2 is creating UI table view cells from UI views so that we can reuse that same view on its own or in a table view. And normally, we could achieve that effect by writing something like this. Create a dummy cell class. We give it one UIView property, which is the view you want to display. And then we pin it to the edges, which is good, but not great. And generics can actually come to the rescue again. We can create a cell that takes in any UIView type class and does the exact same thing as our dummy class on the left, but now it's reusable. And it can accommodate any view. So that can be an app view, card view, or any view that is of type UIView. All right. So with that, I think we are ready to move on to demo 1, to use generics and take our table views to the next level. All right, so in your conference folders, find this 14 custom views. Go to demo 1, starter, custom views, and open the starter project. And feel free to follow along with the demo 1 markdown file that should be located in your instructor folder. So first, we're going to build and run to take a look at this app. And I changed to iPhone 10 just because I like it better. Recommend you do the same. And we're going to wait for the simulator to run. Make it a little bigger. All right. Slowly getting there. Cool. So this should look familiar. It's basically an app store clone. And by the end of demo 1, it's going to look exactly the same. But the underlying code will be a lot more satisfying. So let's dive right in. In Xcode, go to View Controller, Today View Controller. There we go. And check out the Setup Views function. It's around line 40. And I'm sure this looks familiar. We set the delegate and the data source on our table view, and we register the cell. We can see this whole mess. And then if we scroll down to the cell for row at index path, we can see all of this dequeuing mess that's just not going to do. So let's now go to helpers, UI table view extensions, UI table view plus extensions, and create our table view extension. So let's type in extension, UI table view. And we're going to start off with our register cell function. So func register cell, where we're going to abstract our type to cell in the angle brackets, which will be constrained to UI table view cell class. And then for parameters, we are going to not give any name, and then call it cell class. And we're passing in a cell dot type. Yeah. Cool. And all we're going to do in this function is say register cell class. We're calling the UI table views method of registering. And for the first parameter, we'll just pass in the cell class. And for the second, we'll use the string describing cell class. So we have a unique identifier. Cool. So let me get this out of the way. That's better. So that's just going to register a cell. Now for the dequeuing part. So let's add a new function called dequeue. Dequeue reusable cell. Again, we're going to use the angle brackets to give our type a name, constrain it to UI table view cell. And then here, we're going to pass an index path. So we're going to say for index path, call it index path. And the parameter will be of type index path. Nope, not NS index path. And it will return a cell, which is our abstract type over here. All right. Cool. So first, we'll grab the identifier name. And that will be the same as what we're doing over here, which is just string describing cell.self. All right. And then we're going to do the whole guard mess over here instead. So we're going to say guard let cell equals self dequeue reusable dequeue reusable reusable cell with identifier for index path. And for the identifier, we'll pass in this one that we just created, identifier. And the index path will be the one that we're passing through. And then we're going to try and cast this as cell. And if that doesn't work, we'll throw a fatal error because we don't really want a different type of cell to appear there if it's not possible to unwrap it as a cell type that we've defined here. So for this, we can just do something like error for cell ID identifier. And this way, we know exactly when something bad happens because the app is going to crash. All right, so our fatal error is happening. And then if that all goes through well, we will just return our cell. Now, let's actually use these two things. So let's go back to view controller, today view controller. And let's scroll back up to the setup views method. And instead of all of this stuff, we now simply, we can delete that and simply do register cell. And the cell class will be CardViewCell.self. And that's it. This is around line 40. All right, cool. Now, let's go to the cell for row at index path, cell for row at index path, at around like 65. And we can just get rid of this for now. And we're just going to say let card cell equals table view dequeue reusable cell for index path as CardViewCell. So if I remove this, you'll see that this all looks a whole lot nicer. All right, so let's now build and run to make sure that everything is still working as it should be. It still looks good. All right, perfect. All looks the same. So right now, the cell that powers this table view is essentially a wrapper around this other view called CardView. So let's go to UI.CardViewCell to check out the cell. So as you can see, this is kind of a shell. It's a UI table view cell with a property called CardView. And when that gets set, it calls the setup views methods and adds it to the view. Nothing else. At the same time, we have another cell called appViewCell that basically does the same thing. Now, there is no reason to have this repeated code. So let's change that. let's go to UI generic table view and create our generic cell. Well, this should not be here. Let me remove this very quickly. And this. I'm going to do it again. All right, so this is a shell for our generic table view cell, where we have to pass our abstract data type, or set it, name it. So we're going to name it view, and it will be constrained to be a UIView class, basically. OK, so this cell will now have a cell view that will be of type view, any UI view that we pass through. And when we set that, we will call the setupViews method. Let me remove this again. So in our cell, we name it view. That is constrained to UI view. We assign the cell view property to be of view type, and we call setupViews. And in the setupViews, what we'll simply do is say, OK, if the cell view exists, so guard let cell view equals cell view. If it doesn't exist, we'll just return. And if it does exist, we'll add it to the subview. So add subview, cell view. And we will pin the edges to the super view. Well, this is like a convenience method I made somewhere in the style guide section. You can check it out. But it's basically just setting the constraints for left, right, top, bottom. All right, cool. So now that we have this, we can go back to view controller, today viewController.swift, and we can swap out our CardView cell that we have here for our generic cell that takes in any view. So scroll back up top to the setupViews method in the today viewController.swift, and in this register cell, instead of saying CardViewCell.self, we'll now say generic table view cell that will take in the card view type and then register itself the way we did before. Cool. And now the final thing is to update the, let me scroll back up to the top just in case people didn't get it. All right, so now the final thing is to make the same thing happen here. So we're actually going to unwrap this as, we're going to cast this as a generic table view cell that should have the card view as its view. All right, so now this needs to be changed to cell view because it's generic, so it's no longer a card view. And this needs to be changed to cell view as well. And we're done. Let's build and run for the final time to make sure that the app still looks exactly the same. So now anytime that you, and so it does, so anytime you want to use any custom view as a UI table view cell, you can just do that by using generic table view cell and passing in the view that you want. And if you check out the code in demo 2, you'll see that it's being used to power not only the table view of this whole entire collection, but also this table view. And it's getting past the app view. All right. So we have just created a much more flexible and reusable table view architecture. So now that we spruced up the code, it's time to dive into some animations. I'm going to close out of here and go back to the demo. All right. So this is a beautiful example of a custom modal presentation. It's very smooth, it's bouncy, it's got a little bit of that parallax thing going on. It's basically an extremely satisfying user experience. But normally, modal presentations don't look this great. The majority of apps that you find use the traditional way of view controller presentation. You create the view controller, and then you present it. It comes up from the bottom, and it's just kind of there. Bam. So some people go as far as adding a transition style and a presentation style. But based on how many apps I see using this, it seems like an advanced sort of technique. But there is such a big opportunity here for you, the developers, to separate your app from this herd of sameness and create a lasting impression on your users. All it takes is a little bit of work to subclass UIView controller animated transitioning, set that as the transitioning delegate on your view controller, and voila, your app now has a voice. So how does this all work? Well, the transitioning API has plenty of protocols that allow you to customize pretty much any part of the presentation or dismissal interaction. So each view controller has a transitioning delegate. And that transitioning delegate provides an animation controller. When a view controller is about to be presented or dismissed, UIKit checks in with the animation controller to understand how to present the next view controller. This animation controller has to implement the UIView controller animated transitioning protocol that allows it to create a transitioning context for the transition. And this transitioning context has like a bunch of all of the necessary properties for you to create your animation. It has access both to the view controller we're presenting from, the from VC, and the view controller we're presenting to, on top of having a container view where you can do your animations. That is like a blank canvas for you to play around with, and that is where all of the magic happens. All right, so now let's take a look at the animation in slow motion. So what we can see here is that when a user taps on a card, the card scales down a little, and then a bunch of stuff happens to make it look like that. So it's actually easier to look at this through a couple of crucial frame outtakes. So the first picture shows the app in its normal state. The next one is a little bit after the user touches the card, and the last one is right before the transition completes. So breaking this down, this means that in our presentation, we have to dim the background, blur the background, resize and straighten this image, and then unscroll the text view that lives on the presented view. So easy. Before we go to the actual demo, let me just give you a brief overview of this view that powers the cells on the Today tab. So this is the card view. Digging in a little deeper, it looks like this. It has three main views. The content view, which is actually the content view of the cell. The shadow view, that gives it a nice little shadow effect. And the container view, which is what actually holds all of the content. And I'm explaining this because in a few moments, when we're live coding, I want to make sure that you understand what we're working with. So the other interesting thing about the card view is that it has this property called view mode. And the view mode goes from card to full. And the main thing this view mode change does is that it updates the constraints of the card view and the corner radius from slightly inset constraints on the left and rounded corner radius to 20 to no insets and no rounding. And the background image itself, interestingly, doesn't change with the constraints. And that is what gives it that nice parallax effect, that the image itself stays the same. All right. I think we are ready to roll. OK. Let's go back to our tutorial, custom views. Go to demo 2. Don't continue from demo 1 because some things have been added that are not in demo 1. So make sure that you start off with demo 2, starter, and open the starter project. Fun. All right, let's expand this thing all the way. I'm going to change it to Xcode. Sorry, iPhone X. Cool. And feel free to follow along with demo 2 Markdown that is in your instructor folder. So first, let us just do a build and run to see if anything has changed with our app. All right. OK, so stayed pretty much the same. But now, when you tap on the view, a detail view controller actually shows. So but it looks normal as the normal modal view presentations. So our job in this demo is to change that. So let's go to Transitions, Transition Manager. And here, this is the class that will be controlling all of the animation and transition logic. So you can see we have subclass, the UIView controller, animated transitioning. Right now, it's kind of a shell that has a couple of properties defined and basically conforms to 2 necessary methods. The transition duration, which is the amount of time that the transition is going to last, and then animate transition using transition context, which is where all of our animations will take place. So this is a pretty long method. So I'm going to ask you here in the isPresenting block at line number 91 to change this to false for a second. And what this is doing is that when the detail view controller is presented, we were hiding the views, but we want to show them so that we see that our transition is working. All right, we'll deal with this later. But first, let's go to our Today View controller, and we're going to give our view controller the transition delegate. So go to View Controller, Today View Controller.Swift, and at the top, we're going to define a new property. It's going to be a private let transition manager, which will be a transition manager, just like that. All right, cool. So now let's scroll down to the did select row at index path. And we'll see that we're doing our normal presentation here. And so before we actually present the view controller, we want to give it the transitioning delegate. So we'll do that by saying detail view controller dot transitioning delegate equals transition manager. It's very close to the edge. And then the next thing we have to change is say detail view controller dot modal presentation style is over full screen. All right. So when you've got that, build and run to see what happens now when we tap on that cell. And let me move this a little bit away. When we set the modal presentation style to over full screen, that just ensures that the views of the presenting the Today view controller, this one that we see right here, don't get removed while our detail view controller is getting presented. All right. So we have our presentation. It works, but it's obviously not what we want. What we want is this. And to do that, we have to take the card view and animate it into position. So how are we going to do that? First, we'll make a copy of this top of the card view so that we can manipulate the copy without affecting the original. Then we'll place the copy on top of the original so that it doesn't interfere with our animation, and we'll hide the original so that the animation of the copy can be seamless. All right? Then we're going to take our copy, and we're going to de-round the corners and pin it to the top of the screen, which will be a simple transition from card view mode to full. Okay. And then finally, we will show our detail view controller. All right. So let's now make our way to transitions, transition manager.swift. All right. So first, we're going to make that copy of the card view. So luckily for us, a method that does just that has been provided for us right above the transition duration function at about line 66. It's called create CardViewCopy. There's a little thing missing over here, which is setting the frame of the new CardViewCopy. We'll be doing more frame animations and constraints just because it's a little simpler and faster to do in the demo. All right, so what we have to do here is tell the card view what its frame should be. So we'll say CardViewCopy dot frame equals card view, which is the original card view, dot, let me remove this, convert this CG rect, which will be the card view dot frame to nil. And what this is going to do, this is going to take the absolute frame of the original card view and set that frame for the card view copy. And we're doing that because we need to tell the card view copy where to position itself when we plop it onto the screen. All right. Everyone got that? Cool. OK, so now let's scroll down to the animate transition using transition context again. And here, at about line 90, we already have a reference to the card view. And we're just making sure that we're grabbing the correct one based on whether we're presenting or dismissing. OK. So now we'll make our copy. So we'll say let CardViewCopy equals create CardViewCopy, and we'll pass in the card view. Cool. Let's go a little up. OK. So now, in the isPresenting block, we'll hide the original card view and add the copy to the container view. So we'll say card view is hidden equals true, and then add to the container view dot add subview, and here we'll add the card view copy. All right. Cool. So now that we have the card view copy on the container view, we have to scale it unround it, and pin it to the top, which seems like a lot of stuff to do. So we're going to just put in a new function. And if you scroll down, there's this move and convert card view, appropriately named, where we can do just that. OK. So here, we're going to pass in the CardViewCopy, the container view of the transition context, and a completion block to do stuff after the animation ends. So what we're going to do here is first, we are going to lay out the card view so that if anything needs to be laid out, it gets laid out. So we'll call it CardView.layout if needed. And then the next thing we'll do is say CardView, update constraints for CardView mode, and that will be CardView mode full. So currently, it's at card, and it's going to go to full. And now we create our animation, which will be a spring animation, a UIView built-in animation that gives us a little more control over bouncy stuff. So we'll say UIView, animate spring. And you're going to see this block of parameters to pass in. So for the duration, we'll give it 0.6. Oops. We will have no delay. We'll use spring with damping and give it a value of 1.0. The initial velocity will be 0.5. The options will be curve ease out to give it like a nice rounded animation. And then for the animation, just press enter for now. And do the same in the completion. Completed. And then at the end, call the completion block by saying completion and calling that thing. All right. Almost there. So in our actual animations of what we're going to do, we have to first deround. So we're going to say CardView, ContainerView, layer, corner radius equals 0. So don't round the corner. And then we're going to move the CardView's frame and move its origin, y, to 0. And at the end, we have to call layout if needed again, so that the constraints animate nicely with the animation. So we'll say CardView, layout if needed. All right, cool. One more step with this. We have to call this method. So, everyone seems to have stopped typing. OK. So now, let's go back to the animate transition with transition context function above in this isPresenting block. And we're going to call the function. So right after we add this CardViewCopy subview, we're going to say move and convert CardView. And we'll pass in the CardViewCopy. We'll pass in the ContainerView. And for this, we will say 0 at the moment. And for the completion, we will now take this line where we complete the transition on the context and strip it out of here and paste it in the completion block. All right. So let's build and run to see what we have created. I'll move this up a little. Now we can see that the animation works out pretty well. But we can't dismiss, and the card view, the original card view is still there, and it's not looking quite right. So what we have to do at this point is make sure that we hide these views for the two view controller that we unhid before. So we'll say true to this. So before we move into our funky animation stuff, we hide the detail view controller's views. And then when we're back here, we make sure that they show again. So we'll say to VC, views are hidden equals false. And at the same time, we'll make sure that the original card view is not hidden anymore. So card view is hidden equals false. And that we remove the CardViewCopy from the super view so that it's not in the view hierarchy anymore. So CardViewCopy, remove from super view. All right. Let's build and run to check out our new animation. Slowly getting there. There we go. All right. So that's looking a lot better, but it does seem a little lifeless. It just kind of goes up to the top. Doesn't really care. So I think it needs a little more bounce to make it look alive when it's moving to the top. And unfortunately, that's not something that's super easily achieved with the built-in UIView animation option, so we have to go one level deeper to CA layers to achieve this effect. So let's scroll down to YOrigin move and bounce animation function that creates a CA spring animation. And that will give us a lot more granular control over all the possible animation properties. OK, so let me explain what's going on here. First, we create our CA spring animation for the property of position Y of a CA layer. Then we give it a little bit of damping. The default value is 10, and higher values just mean that bouncing will finish a little faster. Then we give it an initial velocity that starts off at 0, and higher values, like 7, give it more initial momentum so that it starts off fast. Then for the mass, the default is 1. We're giving it 0.9, and that is going to reduce the spring effect a little, but in a different way than the damping itself. So it just results in a slightly longer settling duration. Then this line is like an API flaw, where you have to assign the settling duration of the animation to the duration of the animation. That is bad on Apple. Then the next line is saying that we're adding this animation to the current layer rendering animations that are going on, so we want that on. This is saying that we will not remove it on completion so that our view stays where we animated it to. This is saying the same thing. And here we're assigning what value we are animating from. So that's always going to be 0. And then we'll just move it somewhere else at the end. All right, so that's our animation. And we can go up to our move and convert card view to add this property to our animation. We're going to say let YOrigin animation equals YOrigin move and bounce animation. All right, and then inside the actual animation block, we can replace this manual frame moving by saying YOrigin animation dot to value. So now we're actually telling it where it should animate to will equal 0. And then CardView dot layer. So we have to add that animation to the CardView's layer property. So we say CardView dot layer dot add YOrigin animation for key, and we can just call this Y move and build and run. So this Y move doesn't really matter unless you are trying to target specific CA animations through like the delegate methods. So you can name it whatever you want. Cool. All right, so that, doesn't look quite right. But that's because we're not properly moving the to value. Like this, we can't move from 0 to 0. So now we actually get to use this extra parameter in this method that you might have been wondering about, called YOrigin to move to. So instead of saying 0 for the to value, we'll say YOrigin to move to. Actually, we'll say minus YOrigin to move to. Cool. Now let's up. Oh, it's because the origin that we're getting is the opposite value. So either we change it from when we're passing it through, or we change it at this end. And I decided to do it at this end. Yeah. So, OK. So now we want to go to our animate transition using transition context in our presentation block, and make sure that this YOrigin to move to is an actual value. And this value will be the origin, the YOrigin of the CardViewCopy. So we'll say CardViewCopy dot frame dot origin dot Y. All right. Let's build and run. And see if that worked out. Cool. All right. That looks better. Bouncy, doing all that stuff. There we go. So much better. So we're almost there. There's just one thing missing, which is the bottom. So the after has this nice unfurling effect before it shows the text, almost like a scroll getting unscrolled. And just like before, it's easier to show than to describe this. So what we have here is our card view on the Today View controller. So it consists of a content view, shadow view, and a container view. And the effect we want to achieve is the unscrolling underneath it. And that happens at the same time as we expand the card view. So we're going to try to add in a view, like a white view, underneath the container view over here, so it goes above the shadow view, so that the transition is seamless and that the shadow view doesn't really bug us in between. And we're going to deround that view, that white view. First, make it the same frame and size and roundness of the container view. Then deround it and kind of pin it to the size of the container view of the transition context, so it fills up the entire screen. All right. Let's go do that. So back in Xcode, in our transition manager and in transitions, there's already a property called white scroll view over here that is basically just a simple UIView that has a white background color. So what we want to do here is add it to the CardViewCopy right before we add that to the subview. So scroll on down to the isPresenting block. And here, we will configure our white scroll view. So we're going to say white scroll view dot frame equals card view container view frame. So the size is going to be the same as the card view container view frame. And then we also want to make sure that we round it appropriately. So we'll say white scroll view dot layer dot corner radius equals card view dot layer dot corner radius. All right. And then the next thing is to insert it after the shadow view of the CardViewCopy. So we'll say CardViewCopy, insert subview. We'll insert the white scroll view above subview, CardViewCopy dot shadow view. All right, cool. So we have configured the white view, inserted it above the shadow view of the CardViewCopy, and now during our transition, we just have to expand it and deround it. Okay. We can do that in our move and convert card view function. Okay. So let's scroll down to the move and convert card view function, and in our animation block over here, right before we do the layout if needed, we can add this. So say self.whitescrollView.layer.cornerRadius equals 0. So that's going to make it go from 20 to 0. And then we're going to set its frame. So self.whitescrollView.frame equals ContainerView.frame. And just so that we're not confused, this container view is the container view of the transition context. So it's the entire screen, basically. OK, let's build and run for the last time and see if this worked. OK. All right, yay. Cool, awesome. Well, we have just recreated the presentation animation for the Apple App Store. We haven't tackled the dismissal, but we'll do that later. So yeah, good job. All right, so welcome back. So now we have the presentation, and what we have to do is complete the dismissal. All right. In many cases, when you're doing a dismissal and you're doing a custom presentation, the dismissal is going to be the complete opposite of the presentation, which is basically what happens on the App Store app. We laid down this groundwork for the presentation in demo 2, so we should be able to just reuse that to reverse the entire animation. And the isPresenting property that we manage through the UIView controller transitioning delegate will tell us exactly when the view is presenting or dismissing. So we'll know which way to go. All right. But that is not the only way to dismiss the modal view controller. There's another semi-hidden way that happens when the user pulls down on the modal. So the entire view shrinks, it rounds, it blurs underneath, and then reveals the presenting table view. Looks really cool. So as with the presentation, it's a lot easier to see this with frame outtakes. So first, we have our original view. Next, we scale it down, we round it, and we blur the background. And finally, we animate the whole thing back into its original position, which seems pretty difficult. But let's imagine that you can create an image from the current screen and just animate that image. And then things become a lot easier. So let's now learn how to, make a snapshot. All right, so creating a UI image from the current screen is actually pretty simple. There are a few ways to do it, but the easiest and most high-level way is using the UIKit framework. We start off by starting a new image context over here. And an image context basically tells the environment that we're about to create a new image. To start it, we call the UI graphics begin image context with options. And we configure it with some options. So first, we pass in the size of the view we want to capture. And that's just going to be the size of our new image. Next, we pass whether the image is transparent or opaque. And finally, we pass the scale. And if we pass 0.0, the API will just use the phone's main screen scale for us. So we can just do that. And then the function that actually creates the snapshot of the current view is called drawHierarchy over here. Cool. Then we create our image by calling UIGraphics get image from current image context. That's a mouthful. We make our image, and we end the context. Finally, we return the image. So, simple. So what is our game plan? So first, we will create a snapshot of the screen as soon as the user sees the detail view controller. Next, we are going to conform to the UI scroll view delegate methods to listen to when the user is scrolling up or down. And then in the scroll view did scroll method, we'll check whether they are scrolling up or down to know what view to present. All right. So when the user is scrolling up, we'll show them the view controller's original content so they can interact with it as they would. But if they're at the top of the screen and they're scrolling down, we'll hide the contents of the view and we'll show them the snapshot instead. And we'll resize and round as they move their finger up and down. And to do that scaling, we'll use this neat technique provided by CoreGraphics that's called CG Affine Transform. All right. And to figure out how much we actually want to scale the image by and how much to round the corners by, we'll use this scaling factor. The scaling factor is basically looking at the percentage of how much the user has scrolled based around a certain number. In our case, to keep it simple, we'll make that be 100 because we want the resizing to happen fairly quickly. Next, we'll decide where our stopping point is. So how far the user has to scroll before the dismissal transition happens. And that looks like a good 20 points over there. And now we just have to make sure that we call the dismiss method when the Y content offset, so this part over here, is larger than 20 points. And yeah, with that, it is time for the, hopefully, fun part. All right, let me get that off the screen. So go to your conference folder, custom views, demo 3, and feel free to follow along with the conference PDF for the raw steps. So go to starter, and let's hope that the raw steps all match up to what I'm doing this time. Cool. Let's change this iPhone 8 to iPhone 10. And let's build and run. All right. So I've taken the liberty to change a couple of things. We're not going to be reversing the animation because that would just be redundant work. So I've gone ahead and done that for you. And also, if you check out the App Store, you'll see that initially, like the view shrinks down a little and then it expands. So I've added that too, and it's all covered in the transitions, transitionmanager.swift. So feel free to browse the changes in the code here. And for the dismissal transition that happens, much better than before, you can check out when I'm using the isPresenting as a ternary operator, which is basically driving whether it's like gonna present or dismiss. Okay. So what we want to do is do a dismissal when the user pulls down. Okay? So head on over to helpers, UIView plus extensions, that's over here, .swift, and scroll down to the bottom. We are going to create a UIView extension to create our snapshot. So, extension, UIView. And first, we will begin the graphics context, image context, by saying UI graph, sorry, oops, UI, come on, you can do it. Oh, yeah, you're totally right. First, we're gonna name the function that we wanna create. Func, create image. All right, we're gonna create our function that will return a optional UI image. And then in the function, let's get rid of this guy. We will now call UI graphics begin image context with options, where we'll pass in the size of the frame, which is frame.size. We'll say that it is not opaque. And then for the scale, we'll just pass in 0.0. Then we'll take the snapshot by calling draw hierarchy and the frame. And after screen updates will be true. So this is taking a snapshot. Then for our image, we'll create it by calling UI graphics get image from current image context. I hope that you're using autocomplete for these, because they're kind of hard to type. And then at the end, we'll end our graphics context by calling UI graphics end image context and return the image. All right. So that will be our function that creates a snapshot of the entire screen. Cool. Cool. So now let us make our way to view controllers, detail view controller.swift. And let's scroll down to these convenient create snapshot of view function. There we go. So in this function is when we're going to actually create our snapshot when the user first opens the detail view controller and they're scrolled to the top. OK, so what we're doing here is we're just adding some blur, which is a simple UI visual effect view with an alpha of 0.8 that adds the blur to the background. Cool. And then the snapshot view is a simple UI image view that we've just configured with a background color, making sure the interaction is enabled so they can scroll it up and down, and then giving it a little bit of shadow so that it offsets that from the background blur. All right. And now the final step is over here, where we want to add our snapshot image. So in the create snapshot of view function, at around line 163, we'll say let snapshot image equals view create image. So that is going to take the snapshot. And then we're going to say, I'm going to assign that image to our snapshot view. So we'll say snapshot view.image equals snapshot image. All right, cool. So we're initially going to hide the snapshot view from showing because we want to create the image immediately when the user hits the detail view controller. And that's the easiest way to just make sure that it's scrolled to the top and that everything is visible. So we're initially going to hide it, but we're going to create it in the viewDidLoad method. So scroll up top to the viewDidLoad method. And right after the setup views, call the create snapshot of view function. Cool. All right. So that creates our snapshot. And now the next step is to listen to the scroll view. OK. So scroll all the way to the bottom. And in this extension here, detail view controller already conforms to UI scroll view delegate. It conforms to the scrollViewDidScroll method and has a couple of constants defined. The Y position for dismissal, so how far a user can scroll before we call the dismissal function. And this Y content offset, that is just kind of a convenience to grab the Y content offset of the scroll view. OK, so when the user is at the top of the screen and they scroll up, we want to make sure that the whole screen is shrinking and rounding. And in that case, we're going to show them the snapshot view. If they're scrolling down, they need to be able to interact with the actual view. So we'll show the real view, and we'll hide the snapshot. Easy. So if the Y, let me give some more space over here. So if the Y content offset is smaller than 0, they're scrolling up, we will hide the views with this convenient views are hidden variable and set it to true. At the same time, we will say for the snapshot view is hidden equals false. So show the snapshot view. Else, we will do the exact opposite. We'll say views are hidden equals false. And then snapshot view is hidden equals true. All right. Let's go ahead and build and run to see what we have. And the code is here for you to check out. OK, so let's present our detail view controller. And let's see. We can successfully scroll down, as we were before. And now when we take it down, we see that there's a blur added. And this is actually an image that is scrolling around. And if we scroll down, it's still a real view. Cool. OK. So now the next step is to get a scaling factor and scale the whole thing and give it some rounding. OK. So how we're going to do that is we can get a scaling factor. We can do it inside this, if Y content offset is smaller than 0, we'll define a new property. Let's do it after this one, actually. We'll call it scale. So let scale equals 100, which is our number to make sure that the scaling happens fairly quickly, plus Y content offset, so how much they have scrolled down, divided by 100. So this will always be less than 1, because the Y content offset will be negative. And then we will transform the snapshot view and say snapshot view.transform equals cg-affine transform. And we'll use the scale one. And here we'll just pass scale to both scale x and y. All right. So we've got the scaling down. Now we have to also gradually round down the corners. We'll use 20 because the 20 corner radius is what we're using on our original card view. And it's also convenient that that is the limit at which we want to dismiss the view. So we'll say snapshot view dot layer dot corner radius is. So in the case that the user has scrolled further than 20, their finger's gone further down, we want to make sure that the corner radius remains at 20. It doesn't go past that. So we'll check. We'll check if minus Y content offset, that is going to be negative, is bigger than 20. If it's bigger than that, if they scrolled very far down, we'll still keep it at 20. And if not, we will just make it be equal to minus Y content offset. So as they scroll, the corner radius will equal the content offset until it hits the max point of 20. All right. And then the last step is to dismiss our view. So if the Y position for dismissal plus the Y content offset, so if our max that we decided, which is 20, plus how much we've offset it with scrolling, if that is less than or equal to 0, we want to call close. So we'll dismiss. Whoops. Less than or equal to 0, over here. There we go. It should not. OK, there we go. Cool. So let's build and run that and see how it's looking. All right. Moment of truth. Scroll down. It looks cool. Scroll down. And it's a little glitchy. But if the screen updated, we can see that we're successfully scrolling and moving it down to a dismissal position. So it's pretty cool, but it's a little fidgety and happens very quickly. So there's one last thing that I want to make sure we fix. Give it a little bit of time before we hit that 20-point mark to actually complete the transition. So a little bit of breathing time for that. We also want to make sure that the Y content offset never gets over the 20 points that we've defined. So in our if statement over here where we close, we'll get rid of the close for now and instead make sure that the scroll view doesn't move further by saying scroll view dot set content offset to the CG point of X being 0 and Y being the minus Y position for dismissal. So it never moves further than that. And we don't want that to be animated because that's not what we're animating. And then to give it that nice little breathing time, we'll use a dispatch queue and do our close and dismissal after that is done. So what we'll say is dispatch queue dot main async after. And here we are going to say in this dispatch time dot now, which means now, and added 0.2 seconds. That's the breathing time. And then just press enter in the completion block. And here we'll just call self.close. All right. So that should be the final step. Let's build and run for one final time. And see if things are working as expected. All right. So we do our presentation. And let's see. All right. That's looking better. It might not come off on the simulator, but if you run it on a device, I promise it's going to look very smooth. So definitely try it out on your devices. But yeah, that should be that for our last demo. Yes, definitely we should have done that. Well, for now, what we can do is just kind of scroll it up. Like what we have to do is just make sure that if it is up, then it's fine. We can just hide the snapshot view or resize it back to what it's supposed to be. So at this point here, if we're scrolling it up and it doesn't close, we can say that we just want to scale it up back, which would mean we want to transform it. Say snapshot view, transform equals CG find transform dot identity, which means that it's going to transform it back to its original size. We would also have to like deround the corner radius. So for that, we would do something like equals 0 if it doesn't actually go through with that. And I think that should work, but that is the general, like in the other case, you want to make sure that the transform goes back to identity and that you unround the corners. And it should be at the right position then. For now, this concludes the demo part of this session. Let's do a quick recap of all of the stuff that we learned in this session. So first, you learn how to use generics to give your UI table views and cells more flexibility, and learn how to make them more reusable. Next, we learn how to create custom modal presentations and actually implement the Apple App Store one, which arguably, in my opinion, is one of the more beautiful transitions out there. And last, you learned a nice little trick of how to create UIView snapshots and use scroll view to interpolate an interactive dismissal transition. So that is a lot. Good job. So where can you go from here? Well, if you're interested in learning more about animations, we have this wonderful book by Marold Todoro called iOS Animations by Tutorials. You can also watch the book as a video course. And if you've mastered that and want something a little more hardcore, I recommend the iOS CoreAnimation Advanced Techniques. There's also a lot more to discover with UIView controller presentations. For example, you could make your entire own UI presentation controller and make the entire presentation like interactive. That makes no sense. The presentation and dismissal interactive. So to learn more about that, you can read our article, UI Presentation Controller Tutorial, Getting Started. And then another great resource is this Custom ContainerView Controller Transitions by Joaquim Bondo. And lastly, if you need some inspiration, UI Movement is a place for artists and UX, UI designers to post the coolest stuff that they come up with. So all of these should be linked in your conference PDFs, so you can actually get to them. And then if you have any questions, you can ask them now, or bug me later on Twitter or anywhere around the conference. So again, I'm sorry for the mix-up. We'll make sure that the correct files get sent to you. I hope you had a fun time with the session. I had a lot of fun, and thank you so much for attending. I'll see you around.